next presenter that I would like to call upon stage is Mr. Ralph Burgelin, who is the Director Product Management EV Battery Solutions, IKA. The topic of the presentation is Challenges and Solutions of Electrode Mixing. Without further ado, the stage is all yours, sir.
Okay, you can hear me? Good. Last speech we had a kind of overall picture. Now we go a little bit more in detail about a single process step in the cell manufacturing, which is the slurry preparation. Where are we located? At the very beginning of the cell manufacturing process. As this means we get into all the raw materials, they are powders, they are liquids, and now some machinery has to get it into a condition to make a kind of a viscous slurry out of it, yeah, which is very homogeneous and suitable for the downstream coating. It's only a small process step, but it's very important to have a good quality coming out for the process steps, because then all the other steps would be for nothing if the quality would be bad. Just an overview about the typical materials that we have. Yeah, we have usually a kind of a liquid, which more or less only the carrier of the material to the current collector. We have some functional materials like binders to keep the particles together. We have conductive materials for the electric conductivity and some active material for the ion conductivity. And all this we have to get in a certain condition. So the question is now, what kind of mixing system I shall select for this task? Yeah? Of course, most important, the product quality must be good for the downstream process. But also we have to keep in mind all the other things, which is the investment and also for the running cost. So let's go a little bit more in detail about such a mixing process. So basically, we need, of course, a device to mix all together. So you just could imagine a single mixing vessel and an agitator. We put all these ingredients inside and try to make a homogeneous product. But the point is, we have quite a lot of powder material. Yeah, but this can be even up to 80% of solid content of solid material we have to incorporate. So this is a challenge, and that's why we have to need to have care for three main process steps in the mixing sequence. The first is how is to get the liquid and the solid into contact. Also how to do the wetting of the solid materials. Yeah, this must happen in a good way. Then, when it's somehow together, we need a certain energy input. Otherwise, we cannot achieve the product quality, what we need finally to have. And last but not least, all the entire volume, what we prepare, is it the batch or is it the flow rate, should receive the same treatment. So we have really a homogeneous product finally for the coating process. The point is now, what makes it difficult to just to prepare with one single mixing device or single mixing tool? There are different demands of the materials. For example, the binder solution is very difficult to wet the binder powder. Yeah? It's easy to make agglomerates. Similar thing for the conductive materials. Yeah, then we have different change in the viscosity. Yeah? At the beginning, for example, we are very low, starting from a solvent. At the end, we are quite high. So another challenge. And then each of these materials need to have a different energy input. Yeah, it can be, the demand can be very high at the beginning, especially for conductive materials. But for example, for the active materials, we don't want to have too much stress for the particles. Yeah, and like that, we should select a suitable mixing system which fits for all of these materials in each step. Going a little bit more detail about the wetting, yeah. Basically, a powder is a mix of a gas and solid particles. So when we do the wetting, we actually have to replace this gas with a liquid. Yeah, if we just pour it in to the liquid, the powders, or other way, also start from the dry side, then they are easy to form lumps. Yeah, even they can be encapsulated, and it takes very long time to release such agglomerates again. Another thing is, if we just pour it into a mixing vessel, often the powder material sticks on surfaces and are not really in the product. So you have a loss in the final product, or agglomerates which peel off after some time, and the material sticks then in the filter, but it's not in your final slurry. So better way to do is to do it as the inline wetting, as for example described here. So we have an inline machine where in small portion powder and liquid get in contact in a high turbulent area. So instantly the gas volume is replaced by liquid, and there is no way to escape for powder material. Next step, the energy input. Yeah, what do we need to release the agglomerates, yeah, or make the particles as single as possible? Yeah, if the energy input is not high enough, then the particle will remain. You can mix and mix for hours, but it will not change really the final result. So you need a certain specific energy at the tool, at the mixing tool, to release all these forces, which keeps the particles together. Here's a quite overview about different mixing systems. And here you can see also somehow the specific energy input. So it depends now what is the material and what energy level I need to get the particles single and well mixed. Yeah, and based on such requirement should be the selection. Yeah, as you cannot achieve a good quality when the energy input is not there given by the selected mixing system. Last but not least, we want to have the same product quality in the entire volume, what is called here homogenization or homogenizing. And there you can easily see when you have a rather big mixing vessel, a pure batch mix system, then you have quite a big distance for each particle to go to the mixing tool. So when you imagine now such a viscous slurry, it's very hard. All the particles really go there. It's a matter of accident. Yeah, it's a random operation. So you need a long time to be somehow sure the particles are, let's say, passing the mixing tool and are well dispersed. Another thing is the gas room in such mixing systems, yeah, where some material can stuck on. And last but not least, it's a matter then of machine size. How good is the mixing result? Yeah, you are limited somehow from the machine size. Otherwise, the time will be such long to achieve the good quality. It's no longer reasonable to do like that. So now a few slides which explain how it affects now, let's say, the wrong selection. Yeah, as one, of course, can be product quality. Yeah, here now an example about not well dispersed conductive material, which finally affects even in the cell performance. Yeah, for example, for the electrical conductivity. Another thing, but also a major thing, is how long such a mixing process will take. Yeah, you need, it's a very low energy input. It runs for hours. You need manual steps maybe in between to scrape down material. And finally, you have a very small output of such a system. When we change now to an inline machine combination, then this is rapidly decreased. Yeah, this can be done in one machine, but the best is to split depending on the task. Yeah, the machine which are well for the high volume powder incorporation and the high shear dispersing, for example, we use for the binder materials and the conductive materials. After we use an inline machine, a one-pass operation for the mixing of the active materials. And doing like that, we have a very high output and a very good quality, even the mixing time gets very short. Next point, when we want to ramp up a production. Usually, even in pilot scale, if you have such standard mixer, you have to choose already quite a big machine to be sure about, let's say, the processing parameter later on. If you want to increase capacity, the regular case is, let's say, to number up the machines. Do it in inline, it's the possibility to do this by a scale up. Yeah, we don't increase the number of machinery, we just use a bigger machine for each process step. Yeah, and finally, of course, this affects then also for a complete gigafactory. Yeah, if you have now a certain output, let's say here, for example, 10 gigawatt hour, then you would need many very big machines and a peripheral device, a lot of space, a lot of microenvironment utilities, which can be just replaced with one line with just bigger scale-up machines. Yeah, and this as an example how such a modular inline dispersing and mixing system can look like. So if you would like to see more, hear more in detail, yeah, it's a little bit short here in 15 minutes, then please visit us at the exhibition. We are in Hall 1 on booth number 67. Thank you.